Okay, good morning. So I got a question from a researcher about how the Moxy is different from other NIRS devices. I hope I get these questions right. And how the SmO2 value is used and what it means. And to give a little perspective on that. So I'm going to try to do that in a couple of minutes. Specifically to the Moxy sensor and how it functions differently, I'll put a paper in the link that I wrote with Roger Schmitz, the developer of the Moxy. And what the Moxy is differently than, say, many other NIRS devices, there's a lot of different systems out there. There's the continuous wave systems and the spatially resolved systems, the time domain systems, okay, and they all try to deal differently with the path length problem to figure out these different optical properties. What the Moxy does different is that it uses a Monte Carlo modeling system and predetermines different tissue properties a priori. So it says, we have different layers of skin, we have a fat layer, and then we have a muscular layer, and it uses known optical properties of these different tissues to create this model. And the unknowns are then calculated using this kind of Monte Carlo principle. That's how the Moxy really differentiates from other devices, and the reason why we think it's so robust in delivering only, or say mostly, muscle oxygen data rather than this homogeneous tissue system where it just includes your adipose and your skin and your muscles all together. That's what we really think is the advantage, and we think it does a pretty good job. And why do we think it does a good job flows into the next question that was asked, and that is about should we use the raw SmO2 values from the Moxy, or should we some kind of normalize this data? So there's other groups like McCulley's group, and they normalize the data, so they do some kind of calibration process, which generally I think this makes a lot of sense. So I think that this calibration process makes sense, and the calibration process really arises from having relative optical information, so not really knowing what the optical properties say in some kind of absolute value to what the oxygenation is. And if you do a calibration, you can normalize the data to a minimally and a maximally oxygenated state for that person, and then you can scale it 0 to 100% based on your range that you get. And this again makes a lot of sense to do this. Now the one flaw in this is that it becomes a relative calibration for these individuals. It's then hard to compare. I mean, you can compare to a certain extent their percentage-wise what's going on. So you can say, well, one person can get to 0% of their range and doing a certain activity, and another person doesn't. But you really can't compare. It becomes more difficult to compare between individuals. It is clearly possible that someone's calibrated 0% is further away from a true 0% of oxygenation than someone else's. I think that's quite obvious that possibility exists. And I would argue it is empirically provable. So what we are left with now is having this kind of good calibrated intra-individual comparison to losing knowledge between individuals. And I think the Moxy signal does a pretty good job in being able to allow this comparison because of the way that it measures with the Monte Carlo model, assuming adipose tissue isn't too thick. You need to limit adipose tissue to get this proper reading. Now, the reason that I think this is, or why you in my opinion, you can use the raw Moxy values and compare and also draw some conclusions in these comparisons, is that if you do this calibration process with people with limited adipose tissue thickness, you get a very similar response. So people are going to get a signal close to 0% and a signal close to arterial oxygenation. And this does reflect empirical data about what kind of oxygenation ranges do we have. So if you take venous blood draws from people, they get into the 20% during maximal exercise, and we know arterial oxygen saturations are up above 90%. So you already have some kind of a range of arterial and venous saturations. And now we're talking about capillary saturations, so it should function around in that range as well. And from the lower end, it should probably be lower because a venous blood draw is mixed blood. So you would assume that the capillary blood would be lower than that. That's an assumption that we make. I think it's pretty valid, but can be discussed, of course. So I would assume that a real oxygenation scale would be somewhere in the range between 0 and 98%, and probably more realistically somewhere in the range of 10% and 80%. And this is what we see with the Moxy when you do an extended occlusion. So when you do this calibration, you find everyone within a certain adipose tissue get this kind of 10 to 80% range. So it lends robustness to the scale that the Moxy provides, in my opinion, that you can with certain degree of confidence say that the signal that I'm getting from the Moxy itself, the raw SmO2 signal, represents something that is realistic for an oxygenation range, and therefore I'm not going to go ahead and calibrate it because I want to compare this specific value between people. So I don't want to calibrate it down, and you can't do this with THP for the Moxy, for example, which is totally relative. There you would need to do some kind of calibration and set it, bias it to itself. And you'd have to do this with all these oxy and deoxyhemoglobin values as well. This really only works with a percent value, which is actually Gracie's group. I know they mentioned many times they want people to report TSI or SmO2 and THP together. And they feel that's a more robust way of talking about oxygen supply and demand rather than oxyhemoglobin or even deoxyhemoglobin. I think we can talk about that for a bit, but it seems to make a lot of sense to me to report it that way as well. So, which is to the point, you also do need to differentiate between TSI and SmO2. So a tissue saturation index is not going to be the same as a muscle oxygen saturation index. They shouldn't necessarily be the same. They're going to be calculated differently. They also say something different. So you need to really think about, is it an SmO2 that you're measuring or not? And at least the Moxy says it does. And some devices say they do as well. And sometimes I'm skeptical of that based on results I get from these types of calibrations. So if I'm doing calibration and my SmO2 isn't getting lower than 40%, I highly doubt that it's actually measuring muscle oxygenation. It's got to be measuring some kind of mixed value, because it's not likely that SmO2 values would only get that low during an extended occlusion. Quickly to the last point is to the raw values. So the question asked was using Moxy raw values. And when we're talking about Moxy raw values, I think it's important to realize that the Moxy sensor, even at this slow update rate, this half hertz update rate every 2 seconds, it cycles through these 4 wavelengths, which the Moxy uses. I'm going to put a picture up. It cycles through 4 wavelengths, so these dark and light wavelengths, and it does these cycles at 80 LED cycles. The cycles do this 80 times every 2 seconds, so like a 40 hertz type thing going on. To then, and it takes all these cycles together to give you the result. So yes, the update rate that you're getting is only at a half hertz, but really there's a lot more LED cycles happening to average out this data. It makes the signal more robust. So there's advantage and disadvantage. So again, update rates and kind of slower, even though most people end up smoothing this data a ton anyways. In certain cases, it can be a little frustrating not to have fast ones. Again, you can put it to 2 hertz. But just quickly on that, the raw data remark, I wanted to add that. Okay, I hope this helped. Yeah, keep sending some questions. I still have a pretty long backlog. This one came in yesterday, and I liked the phrasing of the question, so I thought I'd just answer quickly or give my opinion. But I know that I've still many other to answer. I'll try to do my best to keep going. Thank you very much. Bye.